Am I audible? Screen. Let me know if the screen is visible.
Hello. Yes, sir. Your screen is there.
Yes, thank you. Okay, so I guess in the previous class, Deepak sir were talking about the TCP/IP protocol and the congestion control mechanism in TCP/IP protocol. So I do not want to disturb the flow, and I do not want to intervene in between. So today I am going to start off with a new topic, that is the application layer protocols. And Deepak sir probably will be continue that topic in the next lab or in the some extra lectures, because we try to finish whatever we can by the end of this week, so that we can give you some spare time in the next week, right? So that is what the idea is, right? So we are trying our best to wrap up all the topics in this particular week. So yes, Deepak sir would take one or two extra sessions, and we'll try to finish off the remaining part of say the congestion control mechanism. And I'm going to start off with the new topic, that is called the application layer protocol, right? By the way, all the reference material, all the PPTs for all the layers, including network layer, TCP layer, application layer, as well as we have some discussion coming up on the network security and data encryption. So that all the topics are already uploaded in the Google Classroom. You can go and you can visit the Google Classroom, right? You can look at the literature there. Plus, I have also shared a few additional topics, which are anyway additional topics, right? Just for your knowledge and information purpose. They won't have much of the weightage from the examination point of view. But yes, it is there as a part of additional topics which you are supposed to refer to it. It is just a kind of white paper on the network baseline and network management, right? So as a network administrator, how you should manage your network, what kind of document you should prepare, okay, and what kind of baseline you should establish, how do you check baseline, right? So baseline means the point of time in the where the devices were working. So which devices, so for example, a given point of time, which devices are right now functioning in the network and which devices are not functioning. So we try to track these things over a period of time, so that we came to know exactly when a particular device failed, right? So that is called the network baseline, okay. So there are some standard practices and there are some white papers. It is all managerial stuff. There is nothing technical into it, right? It is all about, as a network administrator, how do you manage your network, right? So it's kind of a managerial stuff, and how do you document and how do you manage it? So I think you should be able to work it out, those topics by yourself, right? So you can just refer to it anyway. If you have any doubt, you can reach out to Deepak sir, DCV sir, or to me anytime. That is welcome. But all these material are already uploaded in the Google Classroom. So I think we are good to go with all the material, right? So even if you, still if you face any issue, you want to have any additional help, you just let us know. We'll try to help you out in whatever way we can. So yeah, this is all related to the material. And now let us go and talk about the next layer in the TCP/IP, that is called the application layer, right? So application layer in the TCP/IP is something by which we actually know the network, right? So how do we use network and how do we use network services? So we interact with the network, we generate data, we send data, we receive data, we consume data, and we use internet with the help of the application layer protocols, or with the help of the various applications which are built around the network TCP/IP network state, right? So application layer will talk about some of the very widely used applications, right? So the first thing is the domain name system. Why I'm taking domain name system first? Because domain name is not something that you'll be directly using, but domain name system is an application which is indirectly used by many other applications, for example HTTP and www, right? So my focus here, that on application layer, my focus would be mostly on the HTTP protocol, because HTTP protocol is something that you are going to work in detail when it comes to web programming and web development, and when it comes to J2EE, and when it comes to some higher level technical or professional subjects, like how to develop web applications using J2EE or .NET, or how to develop web application using some open source softwares. So there probably you need to have some idea about what is HTTP and how HTTP is working and what is HTTP request, what is HTTP response, what do you mean by web server and stuff like that. So that is something which I'm going to talk about in a great detail, right? So the major emphasis of this layer, the application layer, would be to talk about WWW, that is World Wide Web, and HTTP. What is World Wide Web? What is HTTP? How they are functioning, and how you are able to get content using web content using HTTP protocol, right? And the idea is that this knowledge would be very useful to you when you go as a web developer or as an application developer in the the real market or in the industry. So there, probably this basic understanding of HTTP would be very much helpful to you. So that is the objective, and therefore I'm going to spend more time on that particular topic. Apart from that, I would also be talking about some other stuff like SNTP, that is Send Mail Transfer Protocol, how the emails are working. I will also be talking about FTP, that how FTP is working, how File Transfer Protocol is working. And these are some of the applications like which we are going to talk about in general, like FTP, SNTP, HTTP, right? But however, there are numerous applications that exist out there, right? Majority of the applications that you see today, they are directly or indirectly depend on HTTP protocol. They are implemented using HTTP protocol. But apart from that, you also have so many other services, application layer services, which you can explore by yourself. But as a part of basic understanding, we'll talk about the most commonly used applications, that is SMTP, FTP, and HTTP. But before go and talk about what is SMTP, what is FTP, what is HTTP, and how they are working, we need to talk about one very important supporting application, and that supporting application is the DNS, right? That is the domain name system. So I hope you remember we talk about the ARP protocol, that is called the Address Resolution Protocol, which is there in the lower network layer. When I say lower network layer, means it is between the network layer and the data link layer. And we say that, okay, this ARP protocol is there, but it is not directly used, right? By when sending and receiving data. ARP protocol is not sending any data. ARP protocol is not receiving any data. It is not doing anything with the data. Then why we use ARP protocol? ARP protocol is a kind of a supportive protocol. So it supports or it helps the main protocol to deliver something, right? Main protocol at the network layer is which one? We have the internet protocol or the IP protocol, right? So in order to make the IP protocol deliver the data at a current address, at a current device on the other end, we require the help of the ARP protocol. And what is the help needed from the ARP protocol? Because in order to send data to the next device, we require the MAC address of the next device, right? So in order to create data frame, we require the MAC address, and then we need to put up the source MAC address and destination MAC address. And that is how the data frame is actually circulated on the network. And that is how the data frame is reaching onto the immediate destination. I'm not saying the actual destination. I'm talking about the immediate destination. So in order to send the data frame out on the network, we require the MAC address. But the problem is that at network layer, we do not know what is a MAC address of the destination. The only thing that we know, or the only thing that is provided to us by the user, is the socket address. What is the socket address? The socket address is a combination of IP address and port number. So we know the IP address of a particular device, but we do not know exactly what is the MAC address of that device. So we cannot send data based on the IP addresses. I mean, we can note down the IP addresses in the IP address can only be useful in deciding the routing algorithm or in deciding what is going to be the next hop device. But when it comes to actually transmitting data to the next hop device, the actual transmission of data online, on physical line, happens using the MAC address, right? The hardware address. IP address cannot be used for the actual transmission of data online. So the role of the IP address is to only determine what is going to be the next hop IP address based on the routing algorithm, right? So you can use IP addresses, you can do subnet masking, and then you can find out the net ID, and then you can compare the net ID with the net IDs which are already available in the routing table. You can find out the match, you can find out the next hop IP address. But this next hop IP address is not going to help you in sending data on the outgoing interface. In order to send data on the outgoing interface, you require MAC address. And therefore, we require a protocol which actually allows us to convert this MAC address into, this IP address into the MAC address, and that is what we call the address resolution protocol. So as such, address resolution protocol is not transmitting and receiving data, but it is helping the IP protocol transfer and receive data at the network layer. Exactly similar to that, we have the DNS system, or we have the domain name server. And the job of the domain name system or the DNS application is to convert the URL, that is the unique identifier of the server, into the IP address. So as I said, that in order to communicate with any device, right, or in order to communicate, if the client would like to communicate with the server, the client would like to know the socket address of the server. What is the socket address of the server? The socket address of the server is consist of two things: the IP address of the server and the port address of the server, right? So the port address of the server is basically automatically identified by the kind of service that the server is providing. For example, if the server is providing HTTP, then we know that there is a well-known port number 80. If the server is providing FTP service, then we know that, okay, the port number is 26. If the server is providing SMTP, then we know that, okay, the port number is so and so, right? So we already know what is a port number depending on the type of service. But still, what we do not know is, or what we need to find out is the IP address, right? What is the IP address of that particular server? So what exactly it is done that if you want to communicate with any of the server, right, what you need to do is you need to remember their IP addresses, right? Once you have the IP address, the port number can be automatically determined based on the service you are trying to access. And then once you have the port number and IP address, then it is possible for you to create a socket, and then it is possible for the client to make a request to the server. Now the next problem is, how do you remember the IP address of so many different servers which are available outside? See, remember, I mean, just to take an example of HTTP protocol, and I mostly will try to take example of HTTP protocol because this is what the central of our discussion, or this is what the main focus of our discussion in the application layer protocol. So just remember that you would like to access website of thousands of different companies. And in order to access a website of a company, what you need to do is you need to know what is the port address. Obviously, it is an HTTP server, right? A web server is basically an HTTP server because a web server is responsible to distribute or disseminate the HTML document, right? So web server is basically providing an HTTP service. So since it is providing an HTTP service, the port number of the web server is 80, is going to be 80. तो चाहे वो DDU का वेबसाइट हो, चाहे वो गूगल का वेबसाइट हो, चाहे वो फेसबुक का वेबसाइट हो, निर्मा का हो, MSU का हो, या किसी और कंपनी का, XYZ कंपनी का वेबसाइट हो, they would be running their web servers always on the port number 80. This is we know for sure, right? Okay, if it is HTTP, it is going to be port number 80. We did not to know that, right? We did not to find out what it is. So since it is a well-known port number, we already know, right? Infosys का website है, TCS का है, company का है, college का है, किसी का भी website है, the port number is going to be 80. But in order to create the socket, what we need is we need to create we need to find out the IP address. So IP address of different website would be different because it is uniquely identifying the location of the server. So DDU का IP address अलग होगा, Google की website है उसका IP address अलग होगा, Infosys की website है उसका IP address अलग होगा. So every website will have a different IP address. So what we need to do is we need to remember the IP address of all these websites. Right? अभी हम लोग website कैसे access करते हैं? We say that, okay, it is www.infosys.com, right? But actually, this doesn't help. In order to connect to the Infosys server or web server, we need to have the IP address of that particular web server, right? तो अगर इतने सारे IP address हम लोग remember करने जाएंगे, then it will become a very cumbersome because humans are very poor in remembering digits, because an IP address is nothing but it's just a digit, right? It's just a bunch of or a combination of digits. आप में से कितने लोगों को अपना खुद का फोन नंबर जुबानी याद है, right? अपना खुद का, right? Maybe 90% of them, I would say 99% of them probably will remember. Some of them will not knowing its own phone number. उसने कहीं पे लिख के रखा होगा कि हाँ ये मेरा phone number है, right? Now you go and if I ask you that how many of you remember the phone numbers of your parents, right? You do not have to look it into the telephone dictionary and your contact list and find out, like you remember those numbers on your own, because we are very poor at remembering numbers, right? We hardly know our own phone number. We hardly know the phone number of our parents, maybe our mom and dad. But if somebody asks you to find out a phone number of our siblings or somebody like our uncles or aunts or some cousins, then we probably will not be able to recall those numbers. Why? Because the humans are very poor in remembering digits. but we definitely remember the name, right? हमको पता है कि मेरे cousin का नाम ये है, मेरे uncle का नाम ये है, मेरी auntie का नाम ये है. And if we can remember name, then we can prepare a kind of dictionary which we call the contact list in our phone or our mobile phone, and we can save this mapping that okay, this name, this number, this name, this number. So when we are dialing the phone, actually in order to dial the phone, we require the phone number. But we do not type on the phone number, we type the name of that person to which we would like to call. तो हमने वो पर्सन का नाम टाइप किया, उसका फोन नंबर ऑटोमेटिक आ गया, एंड देन वी से कॉल, राइट? वी प्रेस अप द ग्रीन बटन एंड देन द कॉल इज ऑटोमेटिकली एस्टेब्लिश. तो हमको लगेगा कि हाँ, मैं कॉन्टेक्ट लिस्ट में नाम सर्च करके मैं कॉल कर रहा हूं, लेकिन हम नाम से कॉल नहीं कर रहे हैं. रिमेंबर, वी आर कॉलिंग विद द हेल्प ऑफ द फोन नंबर. We are calling with the help of the phone number. So in order to communicate or in order to contact website, the same thing is happening, right? We would like to contact the web servers using IP addresses, but since we are very poor in remembering the IP addresses, therefore we are giving some names to those particular web servers. For example, Infosys का जो web server है उसको नाम दे दिया www.infosys.com. DDU's web server is given a name www.ddu.ac.in. So it is very similar to your phone book, or it is very similar to the contact list that you have in your mobile phone. You have a name, and that name is associated with the number, right? So similarly here we have a name, and that name is associated with the number. The only difference is that the name in our case is called the URL, that is called the unique resource locator, right? And the number that we are having in our case is an IP address. So each URL or each unique resource allocator or unique resource locator, which is basically a bunch of text, which is a well formatted text, is mapped with a particular IP address. Now, when we are trying to make a call, as I said, when we try to make a call, we search the candidate or we search the receiver not with the help of number, but we search the receiver with the help of name. तो हम कॉन्टेक्ट लिस्ट में जाके क्या करेंगे? कॉन्टेक्ट में जाके सर्च करेंगे, लेकिन सर्च कैसे करेंगे? नंबर से सर्च नहीं करेंगे. वी विल सर्च इट बाय नेम, एंड देन वी गेट द कॉरस्पॉन्डिंग नंबर विद द हेल्प फॉर दैट पर्टिकुलर नेम. Similarly, we also need to have certain mechanism here that when we refer to the URL, right, there should be a service which is providing us or which is giving us the IP address associated for that particular URL. And that particular service which is providing you this mapping, right, that is called the domain name system. So this URL is sometimes also called the domain name. Then domain name is converted into the IP address, and that is what the primary job or primary responsibility of the domain name system is. Okay, so any application. So here I have shown the SNTP client, but it is not only the SNTP client; it is an FTP client. Just a minute. Okay, so there is an update that at 1:30 today, Ravindra ji, instead of RAV sir, DCV sir is going to continue with our lab, right, or our sessions. So at 1:30, please again connect back. DCV sir is going to finish off the discussion that we have on TCP/IP, the remaining part of the discussion on TCP/IP instead of RAV sir. So that is the update that we have. Anyway, so where we are, okay, so what I'm saying is that the DNS is the service which actually allows you to convert your name, which is actually a domain name, or we can say a URL, that is the uniform resource locator. It takes that value and it converts that the DNS value or that domain name value or that URL value. It is converting into the corresponding IP address, and that particular IP address is given back to the client. And this client will in turn, using this IP address, it already knows the port number. Now it has the IP address. This particular client now using the IP address and port number would forward that information to transport layer, so that the transport layer can communicate either using TCP or using UDP, right? So that is how the connection establishment process will start, right? So the transport layer will start the connection establishment process and create the connection if it is TCP. If it is not TCP, it will simply send and receive data using this particular port number and IP addresses, right? So here the application, here it is shown that it is an SMTP client, but remember that it is not only the SMTP client, it can be any different kind. Like for example, it can be HTTP client also, it can be FTP client also. Whenever we are trying to refer to some remote server, what we want is that instead of remembering the IP address of the remote server, we can actually remember the domain name of the remote server, and then the domain name of the remote server is in turn converted into the IP address using the DNS service, and then this particular DNS service will in turn help in converting in getting the IP address of the desired client. Okay, so what is the status? So this is on the client machine, this is on the server side, right? So on the client side, we have a DNS client which is running on your local machine, and on the other side we have a DNS server which is running remotely, right? So the local client, it can be an SMTP client or it can be an HTTP client or whatever. This will actually invoke the DNS client, right? It will send the information to DNS client which is installed on the local machine. The DNS client on the local machine will in turn forward this request to the DNS server, and the DNS server will reply back with this particular information, the IP address corresponding to this domain, and then the DNS client will provide this information to this respective client. At the same time, the DNS client will also remember this mapping here. So when the second time, when some other client is requesting the same domain second time, then in this particular case, the DNS client do not have to go and talk to the DNS server, because it is already knowing that what is going to be the value of the IP address for this particular domain name. So therefore, it has to know, it doesn't have to go to the DNS server once again, but it can directly answer this particular query from the local memory itself. So the DNS client maintains a local memory or local phone book, you can say, or local contact list, you can say, that is maintained by the DNS client, right? That is called the DNS cache, right? So any client, it can be an SMTP or HTTP client, will first of all get a domain name, forward the domain name to the DNS client on the local machine. The DNS client on the local machine will in turn forward this request to the DNS server. The DNS server will check the entry. So first of all, the DNS client will check whether the mapping is available in my local cache. If the mapping is available in the local cache, it will directly respond to the client with that particular IP address value. But if this domain name is not available in the local memory or local cache, then the DNS client will make a request to DNS server, and then the DNS server will check whether the entry exists or not, and then it will return with the IP address, and then the DNS client will update the IP address in the local cache. At the same time, the DNS client will return the IP address to the corresponding client, and then the client has the IP address, client has the port number. Now the client is ready to make a connection or forward this information to the transport layer. Okay, so that is what we mean. That is how the functioning of the DNS service is working in, right? So this is called, so how do we refer this domains, right? So how do we, so the important question is that if we are giving certain names to a particular server, how do we give this name? What is the naming convention, right? So whenever we are saving names into the contact list or in our phone book, we always used to have some kind of convention, right? For example, in my case, I always save a name as per the city, right? So if I want to remember somebody living in Nadia, so I will say NDT and then name of the person, right? If I want to contact somebody who's in Rajkot city, then I'll write RJK and then name of that particular person, right? So this is basically the naming convention that helps me identify that, okay, this contact number is from Rajkot, or this contact number is from some XYZ city, or Ahmedabad city, or Surat, or Baroda, or something. Because it may happen that sometimes there are multiple people with the same name, right? There are two people with the name Mukesh. One is living in city Ahmedabad, the other is living in Baroda. So it is easy for me to differentiate between them, right? So that is how we maintain certain naming convention in our local phone dictionary, or in our local phone book. Similarly, when it comes to giving names to the servers, right, we have to have some kind of naming system, right, which is unambiguous, right, and which is uniquely able to identify the servers, right, which can be then listed or which can be then mapped with the IP addresses. So a namespace is the mechanism to be unambiguously giving name to the servers in such a way that this naming convention is unambiguous and the name assigned to machine must be carefully selected from the namespace, so that you had a complete control over how the IP address binding is carried out, right? So there are two different types of namespace. So namespace is kind of a naming convention. How do you assign names to a particular user or a particular server? So there are two different types of namespace that are possible. One is called the flat namespace, and the other is called a hierarchical namespace, right? So the domain names space is actually a namespace which is a kind of a hierarchical name. So in a flat namespace, you simply assign the name. There is no hierarchy possible here. That is, you cannot arrange the names starting from the generalized level to the specific level, right? What do you mean by hierarchy? Hierarchy means that if you can arrange the concept from the generalized level to the specific level, then this is called a hierarchical namespace, right? So in the domain namespace, normally the domain name server or DNS server uses a namespace, and this particular namespace is basically a hierarchical namespace, right? So what is a hierarchical namespace? So hierarchical namespace is actually designed by the names that are defined in the inverted tree structure. Inverted tree structure means what? The root node comes on the top and leaf node comes on the bottom. Normally the tree structure is, it's called inverted tree because root is on the top and leaves are at the bottom. So the hierarchical namespace is actually arranged in terms of a tree structure, and in this particular tree structure, every layer, every level of the tree basically refers a hierarchy in the namespace, right? For example, the top level hierarchy indicates all the namespace, which are all the names which are available in the system. Then the second level of hierarchy indicates that what are the categories or what are the domains. Like for example, whether the server is a commercial server, whether it is an educational server, whether it is organization, or whether it is advertisement or something like that. And so this is called level 1 domain. And then the level 1 domain will have a subdomain, and the domain will have a subdomain, and up to etc. so on. Finally, we identify the actual server which we are trying to connect. So obviously, why we are selecting this hierarchical domain namespace? The hierarchical domain namespace is selected because we are trying to refer or we are trying to connect to the servers in the internet, and these servers in the internet itself are connected in the hierarchical fashion, right? So if we talk about the DDU server, then there is a hierarchical fashion, right? So we have, say, India level ISP, and then India level ISP is connected to the regional ISP. The regional ISP is connected to the local ISP, and then local ISP is in turn connected to the DDU server. So if you try to spot the location of the DDU server inside the intranet, you can say that, okay, DDU server is there on the globe, right? Inside the globe, you can identify the national server. So you can say that, okay, DDU server is actually located in India because the national ISP is Indian. And then you can say that within India, which particular regional ISP it is connected to, within the regional ISP, which particular local ISP it is connected to, and within the local ISP, which particular IP address or which particular location it is connected to, right? So since the design of the network, the intranet, or the design of the internet itself is hierarchical, it makes sense to come up with the naming space, right, which is also an hierarchical and which is closely reflecting the structure or the topology where actually a particular machine is connected inside the network, right? So therefore, we called it as the domain name system, and we say that in DNS server, the domain name space is basically a hierarchical namespace, and in this particular hierarchical namespace, every level is called a domain, and it represents or it gives some information about how this particular device is connected and what is the type of device that we are trying to connect, okay? For example, if I try to take up the example of this particular domain name, so we have a challenger.act.fda.edu, this is the namespace, right, or this is the domain name, then this particular domain name basically refers a hierarchy, right? That is, you have on the top, you have the root node. Root node indicates all the domains or all the machines which are connected over the entire network, right? So आपके network में जितने भी machine हैं, they all are referred by the root node. Now inside that, we go to the domain edu, which gives you some information that, okay, this particular URL belongs to an education domain. Inside the education domain, it is FD, FSDA. FSDA may be the name of the institute. So this could be like, this is a type of the institute, right? So the server that we are trying to connect is basically a server which is belonging to an educational institute. So therefore, you have an edu here. Now inside edu, you have the name of the institute, that FDHA is the name of the institute. Now inside the institute, you have the department. So ATC is basically the name of the department. And inside the department, you have a server. The name of the server is Challenger, right? So this challenger.atc.fhda.edu basically tells you that we are trying to connect a machine called Challenger, which is installed inside an department called ATC. This particular department is inside an institute called FHDA, and this FHDA institute is basically a type of educational institute. That is the kind of information that you can get here, right? So that is how the namespace is hierarchically divided, right? So here we are dividing the namespace. The root level namespace is divided based on the type of institute, but in many cases the root level namespace can also be divided based on the country, right? For example, if you try to look at the DDU website, then what is the domain name of DDU, right? So domain name of DDU, you can say that it is www.ddu.ac.in, right? So www.ddu.ac.in, where the www indicates the HTTP protocol and ddu.ac.in refers to the domain, right? So what we are trying to say here is that I am trying to connect an HTTP protocol which is hosted by this particular domain called ddu.ac.in. What is this domain ddu.ac.in tells you? What it tells you? It tells you that this is DDU, right, which is a kind of organization. AC indicates that it's an educational organization, and IN indicates that it is within India, right? So ddu.ac.in basically tells you that we are connecting to a web server, or we are connecting to an HTTP server, right, which is hosted at the DDU institute. This DDU is a kind of educational institute, and this educational institute is located inside India, right? So that is what you mean by this domain name. Now here, this particular domain name, the root level domain, which is divided based on the country and not based on the service, right? So here you can say that EDU is actually referring to the type of service or type of organization, but here we are dividing this particular domain based on the country, right? So I hope the idea of hierarchical domain namespace is clear to you, right? So let us move ahead here. Now, once you have this particular domain name here, right, then you can find out. So these are some of the example of fully quantified domain name, and these are some of the example of partially quantified domain name. Partially quantified domain name means what? It doesn't have the entire information. It only has certain information possible here, right? For example, challenger.atc.fda.edu, it's a fully quantified name because it has all the information. But if I just refer to cs.hhme, or I just refer to www, this only gives me the partial information about that particular domain, and that is called the partial quantified domain name, right? So so these are called the fully quantified domain name if it gives you the full information, beginning from the kind of where it is connected, right? And whereas the partial quantified domain name only gives you a partial information, right? So as I already told you that the domains are divided into subdomains. The subdomains are in turn divided into sub-subdomains. These sub-subdomains are in turn divided into sub-sub-subdomains and up to etc. so on, until you reach to the actual device, or until you reach to the actual organization or actual device inside the organization which is connected here. See, for example, if I talk about DDU here, then instead of saying ddu.ac.in, currently we have only one website for the entire university. But for example, we would like to have multiple servers, right? Inside DDU, we have multiple servers, and every server is hosting a different website. For example, the FOT website is hosted, right, on fot.ddu.ac.in, right? So this is one server which is hosting the FOT website. Right now, inside the FOT website, we can again have multiple servers where every server is hosting a separate website. So, for example, if I say IT department website, then I could have a domain name like itdept.fot.ddu.ac.in. So this is possible, right? So I can actually go on having any different or any level of hierarchy here, depending on what is my organizational structure and how I would like to host my servers, right? So it is not the case that ddu.ac.in, there is only one server. In ddu.ac.in, there can be multiple servers. One is for FOT, one is for FOP, one is for Faculty of Dental Science and Medical Science and up to etc. so on. So for that, actually, I could have different domains here, subdomains here, and that subdomain in turn may contain different servers which is hosting department level website. So that is how you can come to that level. Okay, so you might be seeing that in most of the IIT system, we have this, right? In IIT, there is not a central website. There is a central website, but it only gives you general information. if you want to have a department specific information, you have to go to the department website. So you can see that CDPT, the CE.IIT or something like that, right? So they indicate basically what that department is, what that institute is, and whether it's an educational institute or not, and in which particular country it is located, right? So that is how you can have this particular hierarchical structure. Now, the distribution of the namespace. So I said that all the websites which are there in the world, they must be having some domain and they must be listed in some kind of server. We call them domain name server. So where do we put all this information, right? So we said that we'll be giving a name of a website or web server, and then we'll be giving them one IP address, right? So this mapping of name and IP address has to kept somewhere so that it can be accessed and it can be notified to the user, right? So where do we put this particular information, right? Where do we contain this domain name, and where do we have this mapping of the domain name with the IP address mapping? Kahan pe store hota hai, right? So one thing is that, okay, we can have some global server on the internet, and we can put all this information on the global server, right? And then we can access this information from there. However, if we are putting all the information in the single server, then this particular system is going to be very inefficient, and it is also going to be very unreliable. Why it is going to be very unreliable? Because if that single server fails, nobody in the world would be able to access internet, right? Because what is the first step in accessing internet, or what is the first step in accessing the server? The first step in accessing the server is to access the DNS first, right? So first you have to get the IP address from the domain. And once you had the IP address, then comes a question of establishing the connection with the server. So although the servers are running, although the websites are running fine, but still you will not be able to access that website because you do not know what is the IP address of that particular server. And the system which is providing you this information is not working right now, right? So this is called a single point of failure. So one particular philosophy is that you can put all the information inside a single server, and then you can ask everybody to access that information from the same location. But there is a risk that if that particular single server fails somehow, or it is not available, then the entire network will be crippled and you will not be able to access any of the services. That is number one. Number two, putting all the information in a single server will also increase the load on that particular server, right? Because so many people are accessing website daily, right? So if you just think of that, there is a single server where the URL or the domain name of all the website are just placed in there, and we are accessing that information from the single server, then you can imagine the kind of load that we can have on that particular server, right? तो दुनिया में आप कहीं भी कोई भी वेबसाइट एक्सेस कर रहे हो, सबसे पहले आपको डोमेन नेम के पास जाना पड़ेगा. Domain name will give you the IP address, and then using that IP address, you can actually establish connection with that server, right? So if you want to go to the domain name for each and every request that you are making to a new website, then you can imagine the kind of load that we are talking about on that particular domain name server. So obviously, putting all the information inside the single server is not efficient, right, in terms of load, and it is not reliable also, because it leads you to the single point of failure. So what are the ways, right? So one of the technique is to put up a distribution of the domain name system on different servers. So let us not put all the information on the same server, but let us just try to put information on the different servers. So the information containing to different part. So all the domain names that we have in the world are divided into various sections or various subdomains, and then this subdomain wise information is actually stored in the different domain name server. So domain name server themselves there is not a single server basically, but there is a hierarchy of server which are storing this information, right, in the hierarchical format. For example, we have what is referred as the root DNS or the root server. The root server is in turn connected with the domain specific server. So you have one server for edu website. So all the edu website are listed here. One server for .com website. So all the .com website are listed here. One server is for ARPA, that is all other websites like listed here. And then we have a country specific domains like all the US specific website are .us domain is listed here. All .in domain is listed on a different DNS, and up to etc. so on. Right? So there is a root DNS which is only storing the pointer to this DNS. So root DNS actually do not store any other information, but root DNS actually maintains only the pointer to the subdomains. The subdomains itself will store the information related to their domain itself, and then subdomain again will not be storing all the information. They would be again divided into multiple
subdomains, and that particular subdomain is only responsible for storing information about that particular institute. For example, you have .in server. .in server will list all the websites which are there in India. Now inside .in server there is another domain that is called ac.in. So ac.in, there is a separate server. So this is in server, and then there is a separate server called AC. So AC server will actually list all the educational institute which are there in India, right? So when you have the domain name here, so when you have this fully quantified domain name here, that is you have this ddu.ac.in, then first it will go to the root domain or root server. From root server it is diverted to .in DNS. .in DNS will in turn diverted to .ac DNS, and then within the AC DNS it will try to search that is there any institute called DDU. So if there is an institute called DDU, that the entry is found, then that particular entry is actually, you find out the corresponding IP address, and that IP address is actually returned back to the client, right? So that is how the arrangement of the physical arrangement of domain name servers are done. So this is called the hierarchical domain name server system, right? Where there is a root DNS, and the root DNS is in turn communicating with the domain specific DNS. Okay, so this particular root DNS is sometimes also called the zone, right? Now this zone is basically referring to a particular domain, right? And then this particular zone in turn may be divided into subdomains and subzones, and that is how the hierarchy is maintained. So a primary server loads all the information on the disk, and so sometimes what happens is that since this particular domains, right, they are very they are very crucial, right? In order to maintain this hierarchy, this root server is very crucial, and this edu server is very crucial. If the server at this level fails, it will only affect a particular domain, or it will only affect a particular set of user. But say if the server at the root level fails, it is not able to connect with any of the subdomain. Similarly, if the server at this level fails, then it won't be able to connect any of the website which are having .edu domain, right? So normally the servers which are there, like at a root level or at a domain level or at a zone level, right? Those servers are having a primary server as well as the secondary server, right? So we do not have a single DNS root, or we do not have a single DNS zone level server, but we have multiple machine. One is called the primary server and the other is called the secondary server. So what is the role of the primary secondary? So primary server loads all the information from the disk file, and the secondary server loads all the information from the primary server. So primary and secondary server are basically they are replica of each other. So whatever changes we are doing in the primary server, those changes are regularly updated into the secondary server as well, right? So this is sometimes called the zone transfer, right? So this is regularly happening. And as and when the primary server fails or primary server is not able to respond, the secondary server can automatically replace the primary server and notify all other domains that now I am going to be the secondary server, and like that, right? So that is how the mechanism of primary and secondary domain name system works in order to avoid the single point of failure. Okay, so DNS is a protocol that can be used on a different platform, right? So we'll try to see what are the types of domain we have. We have already talked about that there are something called the generic domain, that is the specific the domains which are specific to the type of institution, and then there are country specific domain. Country specific domains are actually specific to a particular country, right? And then there is another kind of domain called the inverse domain. So inverse domain actually allows you to do inverse DNS mapping, right? So just like you have an ARP protocol which is converting your IP address into MAC, you have an RARP protocol. What is RARP protocol? That is called the reverse ARP protocol, and the reverse ARP protocol allows you to convert your MAC address into an IP address, right? So similarly in DNS also it is possible to get the IP address from the domain name, and it is also possible to get in the reverse way around, right? You can have an IP address but you want to get a domain name. So normally it is used in the scenario where you have the domain name and you want to get an IP address. That is called the forward mapping. But sometimes it may be the case that you have an IP address and you would like to know what is the domain name for this particular IP address. This is sometimes called the reverse mapping, right? So reverse mapping, for that we have a specific domains which are called the inverse domain, right? So we will also try to see the structure of the inverse domain as well. So these inverse domains are basically allowing us to perform the reverse query where we try to find out the domain name from the IP address, right? Because in most other cases, we'll try to find out the IP address. I mean, given the domain name, our objective would be to find the IP address. But sometimes we would like to do the reverse, and therefore we will be having a inverse domain. So these are some of the general domain, like for example, Aero, Biz, Com, Cooperative, Coop, like EDU, GOV, that is government, Info, right? So these are the MIL, that is military, right? So these are the different kind of domains that we have. ORG, that is the organizations, that is the non-profit organizations, right? .NET, and it's a technology or network-based institution, and so on. Okay, so these are called the generic domain names. Now, inside the generic domain name, then you have a subdomain for a particular institute, right, or a particular organization, and then within the organization, you might also have a subdomain which is referring to different departments and which is referring to different operational units, right? So that is how the domain names are basically created in case of generic domain names. The other kind of domain names are the country specific domain names. So these are some of the domain names. Aero means airlines, Biz means business, Com means commercial. This Com is one of the very widely used domain, right? Because if you'd like to establish a commercial business or website, you probably would love to have this domain that is called .com. Then you have EDU for education, GOV for government, right? Info, right? And like that. Okay, MI is for military, museum is for museums, right? And so on. You can also have the personal domain that you can refer to as name, right? So I can say mgoswami.name. So it refers that this is a personal website of a person named M. Goswami, right? Or Mukesh M. Goswami.name. So it refers that I'm talking about a personal homepage of an individual, right? Whose name is Mukesh M. Goswami or something like that. So these are the different kind of generic domains we have. In case of country specific domain, I can have this like AE, FR is for France, right? US is for US, ZW is for Zimbabwe, and IN is for India, right? JP is for Japan, right? And up to etc. so on. So this is how it is. Now again, inside the country, you may have a specific domain, right? So inside the country level domain, you may have a generic domain here just to indicate that, okay, this refers to what kind of institutions, right? So you say that CA refers to one of the category inside this country US, like for example, AC is the educational institute inside India, right? Or sometimes you see the site says gov.in. What do you mean by gov.in? In refers that it is India, gov refers that it is government, right? So any of the government website that you see, that would be always ending with .gov.in. So .gov.in actually indicates that this is the government website and it is located inside India. Now the government website itself has multiple domains, or maybe the state level domains or something like that, right? So state-wise, you can have another division there, or maybe you can have a department-wise division there. So that is how the arrangement of domain names are done in the country-specific mapping. And finally, we have the inverse mapping. In the inverse mapping, the domain is IRPA. So IRPA refers to that this is an inverse mapping. Now, inverse mapping is, if it is done for IP version 4 address, then it is called in-ADDR. So in-ADDR indicates that we are trying to find out the IP address, that is IP version 4 address. And this IP version 4 address is then listed at 132.34.45.128. So 132 is the most specific address, and then we have 34 here and 45 here and 121 here, right? So if you try to find the domain name from IP address, so you give the IP address as an input. So it will first check that, okay, this is an IP address, it's a reverse query, so it will forward it to ARPA. Then it will check that this IP address is IP address version 4, so it will forward it to in.ADR. And then since it is in this particular domain, it will try to find out all the IP address with matching with ending with 132, and then IP address ending with 34 and 132, and 45, 34 and 132. So that is how the mapping is created hierarchically. And finally, when it matches with all the things like 132, 34, 45 and 121, all the 4 fields are matching, then it will find out the corresponding domain name and it will return the domain name as the response, right? So that is how the inverse domain name is carried out. Now, how do we so we understood what is the domain namespace. It is a hierarchical namespace which has a generic domain, which has a country specific domain. We also understood that this domain namespace is arranged in a hierarchical fashion, right? It is arranged in a hierarchical design. Now, the next question is, how do we perform the resolution? What is a resolution? So resolution is that you are sending the query and then you are getting the response for that particular query. What kind of query you can have? The query basically consists of the consists of the domain name for which we would like to find out the IP address, right? So mapping is the process of converting your one URL into one address into another address. In this case, one address is your URL, that is your domain name, and the other address is your IP address. So process of converting the domain name or URL into the IP address is called the name address resolution process, or simply the resolution process. So how this resolution process is carried out? So basically there are two types of resolution process which are widely accepted in literature. One is called the recursive resolution, and the other is called the iterative resolution, right? So let us first of all try to look at what is a recursive resolution, right? So in the recursive resolution, let's say you would like to first of all find out the domain name for a particular domain. So for example, you are a student of this FSDA institute. This FSDA is a kind of an educational institute, right? So you are a student of that, and as a student you are trying to access a website, for example www.google.com, right? So this is the website. So google.com, you say that okay, www is a type of service. So what is the domain? The domain I am looking here is google.com. This is a domain which I am trying to search at, right? So in order to connect to google.com, we require the IP address of google.com, but we don't have it. The only thing that we know is that there is a domain called google.com, and on that particular server, my objective is to reach the HTTP service, right? So www refers to the HTTP service which I'm trying to connect, which is hosted on the server called Google, right? So that is what I mean by that, www.google.com. Now I do not have the IP address of Google. I just know the name, that is, it is google.com. So what do I do? So client, first of all, so I'm trying to access the website. So first of all, you have an HTTP client. So HTTP client will go to the DNS client on the local machine and say, and will tell him that, hey, I'm looking for the IP address of this guy called google.com. Do you know the IP address of this guy? So the DNS client will check into the local repository, right? We said that the DNS client is maintaining the local mapping of all the IP addresses and names and IP addresses. So that is called the local cache, or that is called the local DNS cache. So the DNS client will first try to check in the register, which is the local register, local memory. Say that, okay, I didn't find this guy. I don't know who is google.com. Let me find out to the higher level DNS. So the DNS client will actually send the request to the nearest DNS. What is the nearest DNS? It is the DNS which is installed at the institute level. So you have the DNS in your local machine, that is called DNS client. The next level of DNS is there at the institute level. So you also have a DNS server installed in your institute, right? Say for example in DDU. So consider this as DDU, right? So we have this root DNS. So you can refer it as a DDU, right? .ac.in, right? So this is what our hierarchy is. So we have this DDU.ac.in, and then we have this is ac.in, right? And then the root DNS here is .in. Now root is in turn connected with the global. I mean, so just for the sake of understanding, I'm taking this example here, right? So this is .in domain, right? So okay, we'll say that, okay, Google, the local DNS do not have this information. So local DNS will forward to the institute level DNS. So it will say that, okay, do you know somebody called google.com? So who is talking? See, remember, not the HTTP client. HTTP client is not talking. HTTP client has forward request to local DNS client. This local DNS client is in turn talking to the institute level DNS and saying that, hey, do you know this google.com guy? Do you have his IP address? So local DNS will say that, okay, let me look it into my dictionary. Is look at the search the dictionary, doesn't find the entry. So he said, okay, I don't have it, but let me try to find out with the higher level DNS. What is a higher level DNS? The higher level DNS is the DNS which is installed, right, at national level, which is hosting all the educational institute. That is AC, right? It is hosting all the educational institute, right? So local machine is asking the institute level DNS is asking another higher level DNS, which is now hosting all the educational institute. And this educational institute domain is now in turn connected with the domain which is hosting all the Indian institutions or all the Indian organization, be it educational, be it commercial, whatever it is, but all the Indian companies are listed in .in domain. So you make a request to the institute level, institute doesn't know it, so it forward the request to the AC domain or the higher level domain. The higher level domain say doesn't know what is the IP address mapping, so it in turn forwards the request to the even higher level domain or say the root level domain. Now this root level domain is knowing everything, right? Say for example, it is knowing all the institutes which are there in India. So let us assume that instead of google.com, we are looking into a company called Google, and this company is actually there in India, right? So let us say google.in. So you don't have in your local, you do not have in ac.in because it's not an educational institute. So therefore Google ka naam isme nahi hai. So it won't be able to search it. Then it forwards it to .in domain. So obviously this is an institute which is inside India. So this .in domain will definitely be having the name or the IP address of this particular entity. If it has an IP address, then what it will do, it will return this IP address to the AC domain. AC domain will in turn return the IP address to the local DNS of the institute. The local DNS of the institute will in turn return this value to the local client, DNS client. And this local DNS client will in turn send it to HTTP client. At the same time, the local client will also update its local cache, right? So all the DNS which are coming on the flow, they all will receive information from the higher level DNS. They will forward it to the next level. At the same time, they will also store in their own cache. So there is also the cache available at institute level DNS. There is also the cache available at this level of DNS and up to etc. so on. Right? So that is how the things are working. Suppose that it is not even in India. It is a global company. It is not there in India. Right? So you send it to a DDU domain. It is not able to find it. You send it to ac.in domain server. It is not able to find it. You send it to .in domain. .in domain is also not able to find it, but .in domain knows that this is .com, right? So this is a commercial website. So what it does, it actually forwards this request to .com domain. So the DNS server of .com domain will try to list all the website, and it finds that, okay, there is an entity called Google. So it will forward the request to google.com, and then google.com will in turn send his IP address back to com. Com will in turn send it back to in will in turn send it back to AC. AC will in turn send it back to DDU, and DDU will in turn send it back to the client, which is trying to access this website, google.com, right? So this particular mechanism is called the recursive mechanism. In the recursive mechanism, remember, the client only has to make a single request. Client ko ek hi request karna hai, and then all other requests are recursively made on behalf of the client. So this server will make a recursive request to this server on behalf of the client. This server will make a recursive call to this server on behalf of this client, right? This domain DDU.ac.in domain will make a request to .ac.in domain on behalf of the client. AC.in domain will make a request to .in domain on behalf of DDU.ac.in and so on, right? So you have to only make one request, and then that request is automatically forwarded to higher level of DNS. And when the response is received, not only the client, but all the DNS which are involved in between, all of them will be updating their cache, right? All of them would be updating their domain name, so that next time when the second request comes in, now when you make this request second time, when you open up the browser again after a while and you try to search www.google.com again, you don't have to go through this process, because that information is already available in your local cache. So you can immediately get this information from the local cache, and you are immediately able to connect to the google.com server, right? So that is the reason you might have observed that when you access the website first time, it is taking a lot of time. But when first time it is loaded, when you try to do it second time, it is very quickly loaded. One of the reason, I mean, this is not the only reason. One of the reason is that because it doesn't have to go for the DNS request once again. Number one. The second reason is that it will load some of the JavaScript and some of the files which are required to run the website. All those files are downloaded and they are kept on the temporary directory. So therefore, when you access the same website again, it doesn't have to download those files once again. So therefore, it is running a little faster. So these are the reasons why the website, when you make a first hit, the first hit is always consuming more time. as compared to the subsequent hits, right? So that is what the reason. That is what the reason is. The second kind of resolution is called the iterative resolution. So in the iterative resolution, the client has to make multiple requests. Like for example, first it makes a request to ddu.ac.in. If it doesn't find it, then it will make request to ac.in. If it doesn't find it, so when you make a request to ddu.ac.in, ddu.ac.in, what it will say that, okay, I don't know it, but this is the address of ac.in. Maybe you can go and talk to ac.in. So then you make a request to ac.in. ac.in will say that, okay, I don't have this address, but maybe you can talk to .in. Here is the address of .in. So you return with the .in address, and then the client will make a request to the .in server or .in domain server, DNS server, and the .in server say that, oh, this is .com. I am only storing information about .in and this is .com. So you probably go and talk to .com. So then you again receive a contact of .com, and then you go and contact .com and up to etc. so on, right? So it is like that. Okay. So I mean, if I just want to summarize it, like if you ask me a query, right? There are two ways I can answer the query. If I am able to answer the query, I can directly answer the query. If I am not able to answer the query, I will say that I am not able to answer the query. Maybe you can go and talk to DCB sir. Here is the phone number of DCB sir. So now you go and talk to DCB sir. So this is called iterative resolution. What is a recursive resolution? Recursive resolution means you forwarded a query to me. So what do? I say that, okay, I don't know the answer of this query. Let me talk to DCB sir, and then I will again come back to you. So you don't have to make a second request. As a student, you have to make only one request. On behalf of you, I will go to DCB sir. I will ask the question. DCB sir will give me answer, and that answer I will update to you also. Right? So इसमें क्या होता है कि both you are enlightened with the knowledge as well as I am also enlightened with the new information, right? So in the recursive design, not only the client comes to know about new information, but all the people who are involved in the process, they all get the updated information. Whereas in this case, no intermediate domains get the information, right? If I give the information of google.com, only the client will came to know about the IP address of google.com. No intermediate servers which are involved in the query resolution, they do not get this information. So therefore, this is not very advisable. Instead of that, this particular design of resolution is more advisable. But however, for the technical point of view, there are two ways to resolve the name. One is called the recursive resolution, and other is called the iterative resolution. Okay, so we'll stop here, and in the next class, we'll try to see what is the structure and format of the DNS messages, right? So how do the DNS query? So there are two types of messages sent by the DNS server. One is the DNS query, which is sent by client to the server, and the other is called DNS response, which is sent by the server to the client. So in the next class, we'll try to talk about what is the structure of DNS query, what is the structure of DNS response. Okay, so thank you very much for connecting here. If you have any issue related to a DNS, what is domain name, what is DNS server, how it is used, right, and how the namespace is arranged, how the DNS servers are arranged, and how the resolution is carried out. If you have any issue, you can raise your doubt, or else you are free to leave the meeting. Thank you very much for connecting today.